How can we find a solution to this differential equation right here that satisfies the initial condition y of 0 is equal to 2? When trying to find a solution to a differential equation, you want to try and get all of your y stuff on one side and get all of your x stuff on the other side. That's what we're going to do. We'll rewrite it first, and we can factor out our x squared here. We'll factor it out. We're able to get all of our x stuff on one side and all of our y stuff on the other side. How do we do that? Well, we'd multiply this side by d of x, which means you have to multiply this side by d of x. You can also divide this side by y squared plus 4, which means we'd also have to divide this side by y squared plus 4. These would cancel, and we divided both sides by y squared plus 4. You can bring that over to this side. Y squared plus 4 d of y is equal to x squared, and we multiplied this side by d of x. To get rid of our d of y and d of x, you just have to do the inverse operation. What's the inverse of a derivative? You take its integral. You just have to figure out how to compute these two integrals. We'll do this one first. That's a really easy integral to compute. The integral of x squared times d of x is just equal to 1 over 3 x cubed plus c. This integral is a little more tricky. To compute this integral, you have to recognize the derivative of arctan is in the format of 1 plus y squared. We just have to get it in this form. To do that, we have to factor out our 4 here. So we would divide everything by 4 in our denominator, and it would give us 1 over. We'll move our 4 in front, and we're going to end up with 4 bracket 1 plus y squared over 4 times d of y. And we need to make everything to the power of 2. How do you do that? Well, you just have to do the reverse operation and root everything. We can also move our 4 out. It's going to give us 1 over 4 bracket 1 over 1 plus y over 2, because we have to take the square root so we can get everything squared, times d of y. Now we can write our integral here in the format of our arctan. It's going to be 1 over 4 times arctan. In our bracket, we have y over 2 plus c. We're almost done here, but if we took the derivative of this right now, we would have not canceled out this. So we'll take the derivative of our inside function to see what we have to write in order to cancel it out. The derivative of y over 2 is just 1 over 2. Cancel out that 1 over 2. We have to multiply our front by 2 so that we can cancel out our inner function. 2 times 1 over 4 is just 2 over 4, and that is just 1/2. So our function would be 1 over 2 times arctan bracket y over 2 plus c. Now that we have figured out our two integrals, we know that they are equal to each other. We'll head over here and we'll rewrite it. 1 over 2 arctan of y over 2 is equal to 1 over 3 x cubed plus c. You only have to write c on one side, because if we add a constant plus a constant, it just gives us a constant. You can also write it as c1. We can isolate for our y, multiply everything by 2, and we're going to get 2 over 3 times x cubed plus 2 times c1 is equal to arctan y over 2. How do you get rid of this arctan? Well, you just have to do the inverse. Take the tan of both sides, which will give us y over 2 times tan to the bracket 2 over 3 x cubed plus 2 to the c1. All right, we're almost done here. We just have to get rid of the 2 that's right here. So we'll multiply this side by 2, have to multiply this side by 2, and we're going to end up with 2 tan of 2 over 3 x cubed plus 2 to the c1 is equal to our y. We can rewrite the c here because 2 times a constant is just another constant. So our general solution for this differential equation would be y is equal to 2 tan times 2 over 3 x cubed plus c. We want to find what the initial condition is when y of 0 is equal to 2. We can plug in 0. That's equal to 2. We have 2 tan in our bracket, and we plug in 0 plus c. That is going to cancel out, give us 0. Then we're going to be left with 2 is equal to 2 tan bracket c. Then you divide both sides by 2. 1 tan of c. What value of tan gives us 1? It's pi by 4. C is equal to pi by 4, which means our particular solution when y 0 is equal to 2 would be y is equal to 2 tan of 2 over 3 x cubed plus pi by 4. This would be the solution that satisfies our initial condition y of 0 is equal to 2.